generally happy with the products, whatever they are buying. I'm not talking only ZSEV, but also competitive products. I think genuinely people are happy with the EVs, what they're buying right now. And they are our brand ambassadors for EV in general, for the industry. And more entries coming into this area will help us grow the market much faster. Just to throw some numbers, like 3 years back, it was not even 2,000 cars a year. But this year is going to be almost 50,000 cars. I'm talking calendar year. So this year is going to be 50,000 cars, EVs in the country. Next year, my estimate is it should be 120 or 130,000. So the kind of growth you are seeing is phenomenal, though as a percentage of the industry, it still remains very low. So if suppose next year we do 110, 120,000 and the market is 4 million, it's around 2.5%. So 2.5% of the market is EV. Which again, from a small base, is not a bad number. But even for this to sustain and grow, what all things we need require. So I think 4 or 5 things I will just highlight right now, and rest I'll not bore you with my speech. I'll pass it on to Hormazd to ask me questions, and maybe we can do the detailing on those questions. But few areas which are important. I think the important thing is the supply chain. The question or the elephant in the room would be in everyone's mind. Okay, we are going towards EV, but what does it mean in terms of transition from fuel? Are we switching from oil to battery? And battery, as myth is that Chinese guys are making the battery more. So are we going to be dependent instead of oil countries to China for battery? And we need to address that myth, because the cell and the batteries are being manufactured by lots of players, Korean players, Taiwanese players, Chinese players, and Japanese players. So it's totally our choice where we want to go to. And the government also is trying to give incentives to produce cells in the country. How fast we can accelerate that, and so that we are energy secured. So energy security is also, and national security is very, very important. So we can always make up our mind that how we want to play this. Like oil, we are not buying from one country. It's a basket of oil, comes from many countries, depending again on all the various issues. So that the whole supply chain of battery is a crucial issue, which I think we don't have the exact answer right now. But I think at this stage, we must make strategic choices, in my opinion. And battery is only one part, but other supply chain items have, motors, controllers, harnesses, battery management system, and a whole lot of things. A lot of startups also are working. So I think we're in a good spot right now to make some strategic choices and take initiatives. So supply chain is one part of it. The other is charging infrastructure piece. And charging infrastructure piece comes again, see, by the way, globally, 90% of the consumers are charging their cars at their home. But in India, we also can define our home in various categories. We live in lanes where the car is parked on the lane. So how do you provide a charger there on the streets? Or you are on the 18th floor in some compound. How do you provide the charger there? Or your resident welfare association doesn't agree with you, and the fast charger situations. So, and we may not have enough load from the grid. So, all kind of charging solutions, not only home solutions, but also the public places solution, where like government is trying to take a lot of initiatives by pushing companies like NTPC, BHEL, and Oil India and other companies to go into this infrastructure, because they have got prime locations for pumps, and maybe that's a good area. So the whole charging infrastructure is one domain where we need to go deep into it. The skilling of people on EV is absolutely important. How do we really take this education to the campuses, to even diploma colleges, to ITIs and engineering colleges, where the students come out with some basic knowledge of EV, and they get, and once they come out with some knowledge, they get practical idea, and they can be the harbinger of this whole knowledge set. Even existing manpower, we need to train them. It's a huge task. And if the industry leaders are not into EV at this point of time, the onus falls on to smaller players relatively, to take this mandate and do it, which becomes quite a task right now. The fourth thing becomes customer handling on EV. Again, you need to give a different kind of a training to your sales guys and after sales guys. How do you handle the customer? How do you handle the customer for EV? Also, because EV is coming not only as an EV, but also coming with connected features, coming with new kinds of touch points for consumers. So what happens is, slowly that may become direct to consumer kind of a sale model also. So direct to so customer handling for sales, after sales, direct to customer. So the whole customer experience may change. Customer expectations may change. They may like to have track and trace model. Just imagine when a courier company can give you a number and you can track where is your package. Why would they not like to know that if they've ordered a car, where is their car? Right? So track and trace and this transparency will all happen along with EV, in my opinion. And I'm using EV as a pivot right now here, but I think more and more this consumer is going to ask. So the whole consumer model probably will change thanks to EV and the new times. And last, I would say even dealer business model will go through a transition as we go forward. Right now, the percentage is very less, so it may not impact in the next 5 years, 6 years, 8 years. But after that, the whole dealer business model in terms of profitability, how much do they make from customers through sales, and how much do they make in service, and how do they make money in service? So that also will undergo a change. So these are the 4 or 5 areas where I think we need to work on. Supply chain, by the way, also includes the recyclability, urban mining of components, because even if you make cell, where do you get the raw material from? So how do you source the raw material? So it's not only about sourcing the mines or taking care of the mines, but also how do you recirculate this whole recovered material? How do you recover and how do you recirculate? So the whole circular economy around the raw material is part of the supply chain. So I'll stop here, and I think I'll pass it on to Hormazd to ask me more, maybe deeper into whatever he feels is right for this audience, and maybe I'll take it from there.
Thanks very much, Rajeev, for those opening remarks. I mean, some very pertinent points you made there. I just want to start off with, your forecast of demand. I think you said for next year about 130,000 EVs, just 2.5% of the overall market. Looking forward, because really it's very hard to forecast. Looking at 2030, when things are really going to pivot, a lot of people say we will still be last man standing in ICE. ICE will grow faster than EVs, but EVs will grow. What is your sense of the EV market by then? I mean, there are some numbers of 7 million, of which 5 million will be ICE and 2 million will be EV, still a sizable number. But do you think the growth will accelerate? Will it flatten out? I know very hard to predict, but since you've come into this game early on, I'm sure you would be having some sense of which way the market is going, and a lot of hurdles also as well, which you have highlighted. It's not a smooth runway. Clearly, demand is there, but again, costs, let's say raw material, supply chain, all that could, be a hindrance. So again, simple question is a longer term forecast. Any thoughts on that?
Yeah, as you said, this is really tough. But the changes are happening so fast around us in the globe, in the automotive space. I think I will not be surprised if this number is higher than some of us think, frankly. So my guess would be, or my bet would be at this point of time in 2030, minimum it's going to be 15%. On the higher side, it's going to be 30%. So, so 15% to 30% of the industry will be EV by 2030. I'm talking four-wheel segment.
And, just looking at, you raise another point on securing, let's say raw materials. So really, it's a very sensitive topic, a topic which is of huge importance because there are a lot of geopolitics involved in it. At the end of the day, we don't have the raw materials. Do you think this is something that could be a concern because, there could be raw materials in countries we don't have good trade relations with, or just the cost of acquiring them will be quite a lot, which would reduce our, or let's say hamper our competitiveness in the EV space. And also, at the end of the day, the battery is the secret sauce. Let's be honest, we are way behind in the battery race globally. China's way ahead, Korea's way ahead, Europe is way ahead. So really, it's all boiling down to the battery, which is really the big challenge and maybe even an opportunity.
So to be very honest, Hormazd, that we are late for sure in this race. We all know it, but the current government is really trying to accelerate it. So that's a good news. And since last 3 years, the kind of discussions and the talks and the policies have come around, makes everyone believe that, listen, we don't have to second guess the government on this issue. Is going to happen, and the government is trying to secure whatever is needed. So now a few things I want to say. If you look at the policy, the government has come out with a PLI policy on the cells very clearly, though not to my knowledge, anything has been announced yet, but I think there are...
I'd like to just, interrupt over there, Rajeev. I think what we understand the ACC policy, which there is, it seems to be a little punitive, a lot of penalties, which if you don't fulfill the requirements, there are a lot of penalties in that for ACC, which is advanced cell chemistry, which is why a lot of people haven't gone in for it. I don't know whether you had any view on that.
No, frankly, I don't know the details, so it will be wrong on my part to make any comments on that. But in general, from policy perspective, I think the government is trying to encourage the cell manufacturing in the country, and hopefully some good bidders and good credible players probably will emerge. I hope so. We all hope so, and we must hope that the government will be trying to do that. Also, see, the larger issue here is that would you like to have all the capabilities developed in this market locally, everything, or you would like to have something like what US is doing when they have come with this Inflation Reduction Act, in which they are saying the supplies for technologies, the high-end technologies, including EVs, they will encourage either source locally or from like-minded countries. Or your friendly countries, things like that. So I'm sure government will be talking about all this and the resource. See, in terms of raw material, on one hand, we all know that it's limited, but on the other hand, we also know that if you maybe spend a little bit more money, then resources can be generated. So like lithium and all, now, through mining, you can do it, through evaporation method, you can do it. And likewise, there are many other, reserve resources, which you can tap. So it may be costly, but you can tap. So, so there are various ways of securing the raw material. So the good news I would say is that at least the government right now is really on top of this whole thing. And when you and I are talking, I'm sure the right people, very, subject matter experts in the government are talking about it day in, day out, that how do we take care of our national interest? That's paramount, and we must do it. And as proud Indians, we all feel that's the way the government should do. So that part is happening. Also, just to conclude this point, I will also say, this whole space is evolving, and by the way, this is not only India issue, it's many countries. And by the way, many countries are even behind us in this race. On one hand, we feel we are late, but many more countries are behind us. So I feel very strongly that India can be a good model for at least emerging market solution. So it's okay, we may not provide solution at this point of time to US or Europe, but to emerging market like Egypt as an example, just take it, or other African countries or Latin American countries, you take it, Mexico, Brazil, you take it, they're also looking for a solution. So we all can join hands, and India, because thanks to our solid engineering, we can join hands and have a good frugal cost, low cost EV solution together by like-minded countries.
Right. No, thanks for that, Rajeev. I think a good point you raised that, we can be a model to other smaller countries and, provide them with solutions as well. I just want to touch upon the fundamental, the prickly issue of cost for EVs. Now, you've been selling the ZS EV for a while. Demand is still there. You can't supply enough. You've not felt the upside of what the demand limit is, even at the price the ZS EV is at. I just want to understand, but, what is really, do you see the hurdles? I mean, we talk about the three hurdles, which is infra, range, and cost. Sense one gets is infra and range are sort of interlinked in a way. And if you're using it in the city, it's not so much of an issue for most of the owners. I think fundamentally cost is the main hurdle, and even to the OEM as well, because I'm sure a lot of OEMs, I know their margins are very thin on EVs. They're passing on all the benefits to the customer just to grow the segment, and still managing, and even the 5% GST is also helping. Just your thoughts on really what can really trigger demand, the one thing that could really trigger demand.
See, I think, we need to have India-specific EV solutions. Like if you think about it, our car industry, the way it evolved in the last 15, 20 years, we had our own, right or wrong, less than 4-meter solution, right? And they're like hatchbacks. The government encouraged hatchbacks, and few reasons were very obvious for that. It was, our roads were not that much developed, the road network, and the parking space was less, and also we wanted frugal fuel economy figures because petrol was always imported and costly. So based on various factors, government went for less than 4-meter cars. I'm not saying it was right or wrong, but I think in all prudence, that was the way it got developed. So in EV, on one hand, you will have requirements from consumers who want 500 kilometers range, who want exotic designs, who want to zip 0 to 100 in 3 seconds, 4 seconds. There will always be some customers, but these customers are going to be very small. Where is the mass market? And the mass market is going to be living in cities where they travel, let's say, 40, 50 kilometers a day, 60 kilometers a day. So theoretically, if they get a range of even 120, 150, decent range, a credible, trustworthy range of 120, 150 kilometers, and they have to charge it every second or third day, they should be happy, right? And how many people they want to carry if you're going to office? And typically what a waste we have, by the way, because if you take a sedan or SUV and only one guy is going, I mean, the whole Ola and Uber concept came because, you are wasting some assets. So here, if suppose there is a small size car which can carry 2 to 4 people comfortably and with some luggage space, can give you a range of 120, 150, 200 kilometers, I think that should be a good practical solution. So it can be equivalent to our Maruti 800 solution. So I think some India-specific solutions, considering our driving pattern, our driving distances, I think we need to have some solution. And that's why I would like to believe our industry's stalwarts, the top leaders, are taking their own time to find the right solution for India. Because you cannot have a very successful imported solution, and when you get this imported solution, like ZSEV, I would say is an imported solution right now. We are doing pretty well. We are selling 700,000-800,000 cars now a month, but again, if you have to, our top cars sell 20,000 cars a month. 25,000 cars a month. So if you want to get to a decent size of 5,000, 8,000 cars per month, you need to have an India-specific solution.
Now, that's interesting, Rajeev, but I think, as you said, India-specific solution clearly means you don't need to have massive range, because range equals cost because of the battery size. Exactly. And we run do small runs. Thanks for that. We are running out of time, but I would like to just, let's say there've been a lot of questions over here, and I think there's some interesting ones. I think one of them is interesting one is, what would be the life of an EV in the context of scrappage policy? For IC engines, it's now 15 years. Also, considering the life of the battery being 8 years, we are then seeing a complete overall before the end of life, assuming it is 15 years also for EV. So clearly, there's no real scrappage limit for EVs. It's not even 15 years. But I think the concern still is on the battery. Still early days because we've just started our EV journey. We've not gone through a life cycle of even a battery in this. But obviously, this is a concern on a lot of consumers' minds. So just
Hormazd, here also, one part I forgot to say, the whole education part, where OEMs and parts manufacturers and like journalists and media, I think we all need to get into an education thing on EV because there are certain myths. This particular question, when it says 8 years life, it's not true. On cars, 8 years we are giving warranty. I think all the players who are in the EV, they're giving warranty. The life can be 12 years, 15 years, depending on the usage. And also, by the way, very theoretically, and I'm oversimplifying. don't hold me for this, I'm oversimplifying, that, if suppose the battery gives you 250 kilometers range, whatever, some battery. So 8 kilometers, okay, it's kind of that, but then degradation starts happening. So it may give you 225 or 200 or 175.
After 8 to 10 years. Yeah.
After 8 to 10 years, doesn't become zero. And then we are talking about second life of the battery also. Can we sell that battery for some other usage after first usage? So there are a whole lot of solutions coming through right now. So I think it's wrong to say the life of the battery is 8 years. The life of the battery can be 12 years, 15 years, depending on the usage. So all these things probably is part of the whole education thing.
Right. And just one last one again, these are slightly consumer-oriented questions, but again, a question that worries on the resale value of EV after 7 to 10 years. This could be a concern for current EV buyers. This is come from Shaukat Zubair to the host and panelist, who's in the audience. So, you've done a lot on keeping your residual value strong. Rajeev, we've seen that with the Hector. But obviously, there are concerns with EVs, which people have. Again, they're still very new. They haven't really entered the pre-owned market in a big way because their launches have just happened. But it's a very valid concern of consumers.
So again, it's a good question, valid concern, and I think a little bit of a myth. Why? Because in India, what we have seen in our market is first generation of EVs in few numbers. Right. So as an example, before the launch of the current generation of cars from us and Tata's, there have been some EVs in the market which were of previous generations. And if you go by the second-hand value of those cars, I think this question is very, very valid. But let's talk about the global examples. Leaf and Teslas have been there. Nissan Leaf and Teslas have been there since last many years on the market. Look at the Google the resale price of those cars, and you will find that either they are at par with ICE engines or they are slightly more than the ICE engines. So because why? You will ask the question why? Because the latest generation of cars are using the latest batteries. These are all NMP batteries, LFP batteries, which are the global standards at this point of time. And they give more life to the battery, more range to the battery. And that's why the life becomes more. So, this research we have done, internally before launch of this car, and whatever data we could get globally, I think that gave us a point that it is at par or slightly more than the ICE. But again, this whole space is evolving. At this point of time, if you ask me, I don't see any concern on the resale price of the EV. But yes, in some cases, if the battery goes down, so what would happen after 5 or 10 years? Somebody will probably say, if I want to buy an EV car, maybe they will do a separate assessment of the battery life, right? Because battery is everything. And maybe then in battery, if you can repair some of the battery cells or modules, then the life gets restored. So I think there will be very different ways of handling resale price of the car after a few years.
Right. Rajeev, thanks very much for your thoughts. It's been really fascinating and enlightening, and even, your predictions of where the EV market is headed. Obviously, you have a lot of hindsight, having been entered this race quite early on. Thanks very much, and really appreciate you joining us. And I think there are so many questions. Clearly, this has been a very, very exciting, let's say, discussion or talk from you. Unfortunately, we can't address all the questions that have come in, but thanks very much for your time, and thanks again. Thank you. And I will just pass it on to my colleague Mayank, who will take over. Thank you.
Thank you.
Thank you very much, Mr. Chaba and Hormazd. That was really a wonderful opening remark for, you've set the context right for this EV forum. And like Hormazd mentioned, we are getting a flurry of questions here, and we'll try to address them in the upcoming sessions through the day. So for now, we'll break out into the first technical presentation session. And I would like to invite Mr. Stephen Dolemons, Head of Market Development, Battery Packaging Platform, EMEA Covestro. Mr. Stephen will take us through his presentation on the topic thermal management and circularity in high voltage battery packs. Stephen has studied materials engineering at the University of Leuven, Belgium, and the IKV Institute in Aachen, Germany. He started his career at Philips in optical storage. In 1999, he joined Bayer and later Lanxess and Covestro. He supported several automotive OEMs in his capacity as global account manager for European OEMs and transplant manager in Europe for Japanese and Chinese automakers. Since 2019, Stevens is leading the EMEA market development team for batteries at Covestro. So I would like to request the audience to keep sending your questions in the Q&A box. And once the presentation is over, we'll take them up with Stevens. Stevens, over to you now.
Yeah, thank you. My short remark first. I can't start my video because it's blocked by the host. I don't know if you can make it free.
Okay,
but else I would just.
Can you just now try doing it?
Yes, I just wanted to ask you to start your video. Okay, there I am. Thank you.
Yeah, good.
Yeah, good afternoon, everybody. Now we'll start my presentation. Normally that should also work. So can you see the presentation, or do you see my presenter mode or the one slide?
We can see the presentation, Stephen, and we're
one slide then. Yep, thank you very much. So yeah, I'm really happy to be here today and that I can share some insights from a company, Covestro. We will talk about thermal management and our solutions also for circularity. I will give you a quick update from the company, then our portfolio, what we will do, and then I will go into our own. We're a material supplier, but we built our own pack, 48-volt pack. And I will show you what we did on thermal management. Of course, mechanical testing is also required, and then we'll go into a summary to conclude. So maybe quickly, I would like to introduce the company. Covestro. Covestro is the old Bayer material science. We have around 17,000 employees and around 15 billion in sales. From the 17,000 employees, we have 1,500 who are working in research and development, and we are in most of our products global leaders. Also in where I'm from, the polycarbonate, we're #1. We have around 50 production sites worldwide. So we're real global company in plastic materials. We sell several products. On the left-hand side, you can see polyurethanes, which are going in also in construction, but seating, composite parts. On the right-hand side, you have solutions and specialties, which are mainly polyurethane-based solutions like coatings. And so we don't sell the coatings ourselves, but where you buy your coatings from, like where Tata buys their coatings from, we are the raw material supplier for that, and also basic chemical development we're doing. But also adhesives, and so we're a raw material supplier for companies who sell adhesives. And then in the middle, where I'm based, and also my colleague Robin Jacobs, who is also in the call, and he's from India. We're from engineering plastics, which is mainly polycarbonate-based plastics and blends. Ourselves, we are from a battery team. We have a global team working on batteries, quite big in China, of course. We just mentioned it, that there is a big industry already since many years, because the lithium-ion batteries are not new to us. We all use them in our electronics. But we also, of course, have a global one, which is in the US, and myself, I'm leading the team in Europe. As a company, we also have a vision, and I think that's a very bold statement, but we want to become fully circular, and that is our ultimate goal, and we're developing also solutions for that. So I'll give you one example later. Let me jump in our portfolio then. As I mentioned before, we have polycarbonate and polycarbonate blends, and our brand name is Macrolon. PCABS blends are called bi-blend. We also have PC-PET, PC-PVT blends, which are mainly used if you need an increased chemical resistance, and they have also very good impact properties. And then a special product is a high heat polycarbonate, which is called ABEC. And if you can see, we also have on the bottom always RE versions, and the RE versions are are bio-based, but attributed over mass balancing. which means that we use raw materials in our production, but we mix them. And then our customers can buy our e-materials, which means that we attribute them. So it's kind of a certificate. It's a kind of, I don't know if you're familiar in India with it, but in Europe, if I buy green electricity, of course, the electrons, I don't know if they're green or blue or yellow, but if I have a contract with a company, they promise to put green electricity on the grid. It's quite similar. We promise, if you buy our E-grades from us, that we will put molecules in our value chain, so in our production. So that's a little bit how the concept. The nice thing about it is that we can use our existing facilities, and we could also in future grow this much more easily to scale these kind of products. If I now come to the batteries and where we are with our products in the batteries. On the left-hand side, first I'll go over the different cell types. Cylindrical cells, typically we have the cell holders. We love cylindrical cells, a lot of plastic parts in it. Also our direct customers, of course, which are molding these parts. And you also would need a bus bar holder. And all these clamshell designs, so we can integrate also the bus bar into the clamshell. So that's typically done in our products, PC, ABS, or PC products. Prismatic cells, there are less plastic parts on a prismatic cell. There it's mainly the insulation plate, also the bus bar, of course, you would need the bus bar carrier and the end plates. And then in pouch cells, it's typically the frames for the cells, but also top plate, and again the bus bar carrier is also very important. And then independent of the cell types, you typically can find our materials for housings. For instance, the motorcycle battery there, the top and the bottom part is a PC PBT material, which has very good impact properties. But we also have high CTI products, which are sometimes used. We just introduced it on the K Fair, on the plastic fair, which is Germany last month, for high volt electronics. Now, the reason why to use PC ABS, I go quickly into that one. So first of all, it's about safety. And if we talk about safety and we look to the specifications, it's about flame retardancy. And the nice thing is our materials, they don't use brominated or chlorinated flame retardancy. And polycarbonate is an inherent flame retardant material to some extent for a V2, for instance, on the UL classification, which means also we don't have to use additives that really impact the mechanical properties. And the material as such is a very ductile material. And since we don't influence the mechanical properties too much with adding these additives, we have very good impact properties. One of the most important reasons, and you just mentioned, Mr. Chaba, also the need in the industry is mass assembly efficiency. And what has it to do? It has to do with the cost, and it is what we are doing. If we look to a Tesla and some other OEMs, they fully assemble automated these battery packs. And where in the past, a few years ago, if I look to Europe, some OEMs, they were doing it by hand, screwing a battery together. But if we want to drive costs down, this is very important. And what can bring polycarbonate to this? Well, we have a very tight tolerances thanks to our uniform shrinkage, and also very low warpage due to the amorphous character of the material. We don't have moisture uptake, so the dimensional stability of a part made in polycarbonate is very high. And this helps us, of course, to bring parts into a mass assembly so that robots can assemble them, can glue them together. And that is also the wide range of joining techniques, gluing, welding these parts together automatically. And that is how we drive costs down. So our battery customers, they need to scale, and they need to scale fast, and they need to learn how the electronics industry is doing that. And that is the interesting what you see in the competing industries. We also see to our suppliers that many suppliers coming from the electronic industry, they're very active in this new electromobility field. And this is one of the main reasons. They know the materials, they have the machines, the equipment to do this. and they're challenging, of course, the traditional suppliers who are adopting, because typically they use materials like polyamide, polypropylene, but they learn also the advantages of using an amorphous, different class of materials that didn't used in the past. And then I'll pick the temperature management, because I will show you what our materials could bring to this. I will give you an idea about thermally conductive materials today. But we also, for instance, if you have in some brands, in high performance brands, they use mineral or dielectric cooling fluids also there. Water glycol cooling systems, our product on the chemical resistance is limited. We can discuss, you can contact our colleagues in India, what is possible, what is not possible. But there, of course, we have to look into the chemical resistance of the materials. And then what we typically offer also is the application development support on, and I will give you also an example of this today. I won't go through our whole portfolio, but I just want to pick one grade which we used what I will show you in the application right away. It's a biblend PCABS FR3040 EV. It's a special grade which you can use for UV curing. So it means that you can use you can cure your glues through the material, so it has a transparency which we can guarantee. So which means that if a molder makes that part, you're sure that at the end, if it comes in your production, that you have the transparency you need for that part. And another one is a thermally conductive material, TC110FR, and electrically insulating. We also have for the several grades, as I mentioned before, our E versions. So the nice thing is with this mass balance, as it are drop-in solutions. So they are co-listed on the UL card. So it's basically paperwork. They have the same properties and everything. I put a link on the presentation, kind of an idea later. We showed there also how much CO2 you can save on typical parts. If that is of interest of you. Then you could use these kind of materials, and I would, then you can contact us or our colleagues in India to discuss that in detail. But it gives you an idea on that link what you could do with such kind of materials on reducing the CO2. Now, let me come to our own pack. And first of all, why did we build a battery pack? Because we're a material supplier, we don't make batteries. But we need to understand also what our challenges our customers face. And we need to develop new materials and to test them in all these new developments we're doing. And also we work with a lot of companies under NDA and so it's not easy, of course, to take the learnings from one and go to the other one. That is not what we can do. So we need real parts that we can test our grades and use and that I can do a presentation like this today, that we have this data, not only we have that knowledge, but we can share it also. So also then as I mentioned, joining techniques are very important, but also potting techniques. And so we can also test these kind of things. Now the pack we developed and we work with is a 48-volt module. With 2170 cells, and it's around 10 kilograms. There is a link also where you can have a closer look inside on the internet page, which you can have a look later if it's interesting. The material that we use to mold the parts, so as you can see the clamshell, we compare two materials, a standard PCABS, this 3040 EV, and then a thermally conductive electrically insulating with around 0.8 watt-meter Kelvin. So not so much compared with steel, for instance, but much better than air and also much better than a standard plastic part. So that is where we molded the different parts, and then we put some thermocouples on different cells. So on the outer cells and in the center cell, and then we did a C/2 charge rate on it to evaluate the temperatures and what does it mean now. And now we compare the two materials. And if you can, and as you can see, in the middle cell, we can have a delta difference of 3 degrees roughly, and the outer cells around 2 degrees. So that is what it brings such a material. Also interesting if you look across the batteries, so the homogeneity across this pack, this module, you can see with a standard biblend, the homogeneity is around 4 degrees, and with a Macron TC, it's 3 degrees. Why is it important? Well, we learned from some customers that the BMS is checking this, and of course, if this difference gets too high, then the BMS needs to interfere. Which means you need to drop your charging or discharging, or you have to interfere in your battery pack and in the module. And it also can show you when it goes further, of course, that you have a more serious issue in your modules or cells. So in that perspective, it is quite important. Also, the 3 degrees, in general, the material is today also already used for battery packs in construction yards, for instance, where workers load their electrical equipment. And I learned from other customers that if you can reduce with 6 degrees, the lifetime of your battery doubles. We just talked about lifetime, so the homogeneous temperature distribution is quite important in a module and in a pack design. So that is where we believe, and some customers believe, it can bring something, these 3 degrees. Of course, something very dependent on the design, of course, and also the other materials, cooling systems you're using. This system is just ambient air, so there is no water glycol cooling system or so, and that is, of course, then something you need to look into detail. Now, making a material that can improve thermal management is nice, but we also have some tests. I will go quickly through that. Of course, we tested that, and we did the thermal test. You had UN 38.3. We did the thermal test, the vibration, the shock, and the crush test. Basically, all different tests were tested in outside, and as you can see on the thermal test, it all passed. Also, the vibration test was passed with the 2 different materials that you can see. The white one is the thermoconductive. The more yellow one is the natural color of PCABS, is the 3040 EV grade. As you can see, also the shock test, and finally the crush test. Also there, we passed with the pack. So, as I mentioned, we use this data to test our materials, and also what we do with this is to have data where we can do thermal simulation. So we validated our own data, and that, of course, is quite interesting for our customers because we can help them to do the calculations or provide them with the right data that they can do these simulations and optimize the design. So in that sense, it's very important for us that we can measure this ourselves. Also, I put a link where you can have a look further to these materials. And there is also, because these materials are not only used in batteries, of course, they're used to where we need thermal management in general, like the lighting industry or the power electronics. Also there you can find, and there is also a calculator where you can have an idea what it might bring to you. And then, of course, if you want to go into detailed design calculations, and so you can contact us and the team can help you. Here you see an example where we did a study ourselves on what it brings and optimizing the design for a clamshell. I would like to come to an end and to sum all these things. So first of all, we built and tested this and looked to the thermal and the mechanical behavior. That was very important. Also, that we successfully could mold this part, because these materials, like a Macron TC, they solidify in your tool. So it's not always easy to mold such materials. But we optimized also the material for molding, also the thin ribs, and so there is some development also in that, and that you can use this for these battery parts. The result is that we can improve with around 3 degrees, delta difference of 3 degrees using in this specific pack design. We also can of course, yeah, just to mention also that this is, of course, specifically for this design. If you have a different cooling system, like I mentioned, an active water glycol cooling system, or you use a dielectricum inside the cell, this is all different. But we validated the material data, and we can support you, of course, with all these materials and simulating them. So this brings me a little bit to the end of a presentation, where I wanted to give you an idea about, on the one hand, how we can help you on this thermal management topic, and of course also quickly introduce you to how we could bring in these more sustainable materials, where you can reduce the CO2 of your parts, which might be, I don't know, personally the situation in India would be interesting to learn that. But in Europe, we have the battery regulation, where you get requirements on the CO2 content. So you have to do an LCA analysis in the future, and where you can get a threshold. And later it will be also used to as a limit. So there will come a limit, and batteries who are above certain level, probably, I would say, because it's not all in place, will have some issues by importing their batteries into Europe. So that is also why these kind of things might be in future important.
Stephen, thank you so much for this presentation. I think it was very insightful. But unfortunately, we have sort of overshot the time. So what I would request you is, if you could just, please stick around, and you could take the questions that are directed by the audience towards you. And if you can just reply to those in the chat box, because they're very technical specific questions. I think if you have the time, it'll be very helpful,
Yeah, I will have a look to the chat link right now. Problem. I will stay in the chat, and also my colleague Robin Jacobs can help me there.
Sure.
And we will share their contact details also. Absolutely. Like you can see.
Absolutely. Thank you so much, Stephen, for that.
You're welcome.
And we'd now like to move to the next session, which is a panel discussion. And I would now like to hand it over back to Hormazd. Hormazd, over to you, please.
Thank you. Thanks, Mayank. Thanks very much. Thanks, Stephen, also for a very insightful presentation. Now we are moving on to the next today's panel discussion, which is interesting topic. It's on decoding the affordability challenge for EVs. As you know, cost is a big issue, and the biggest cost is the battery, but there are ways to lower costs in other ways, like localization, securing our raw materials, developing the supply chain. All of this has a big impact. On the other side, we have government policies which have really worked, especially on the taxation side. Regulations also have an impact on cost and price as well. And now we've got new battery norms, which I'm sure, it's become a hot topic today, how it helps, and, does it also delay launches? And to discuss this and more, we have a very eminent panel today from the OEM side. We have Anand Kulkarni, who is the product line head and vice president of Tata Motors electric car division. We also have Hardeep, Brar, the vice president and head of marketing of sales of Kia India. And on the testing side, we have Ramanathan, Srinivasan, the managing director of Automotive Test Systems. So, gentlemen, thanks very much for your time and for joining us on this panel. I'd like to start off with Mr. Kulkarni, and I think really Tata Motors is the hero of the EV race so far. There's absolutely no doubt about it. Just completely cornered market share. I think it's a combination of a lot of things, but Mr. Kulkarni, just specifically talking on how you've achieved certain pricing where you really set the benchmark for EVs. They're still more than an IC, but it seems there is a direct, and also the direct correlation between price and sales, and really how you really approach, let's say, the affordability factor with your EV range. Obviously, you've got the benefit of scale from they are all ICE derived right now, but in future you will be having more bespoke EVs. But just on the affordability factor, because you seem to have nailed this part better than any other OEM so far. Over to you, Mr. Kulkarni, first.
Hi, good evening, good afternoon. Hormazd, and to all my delegates on the panel today. I think, before I start, I would like to just say that, electric vehicles have a certain way of being able to match up with the entire thing. And when you're looking at the right price to value equation, I want to say that before you do this, let's understand what is happening in the electric space today in terms of how do people use it, what are the use conditions. So there is one application, Hormazd, that people use it within the city. And if you look at city distances today, which one has to look at while configuring a vehicle, trip distances are typically around 10 kilometers, less than 10 kilometers, and people tend to do about 5 or 6 trips on a daily basis. That's what our data is showing us at this point of time, which roughly means about 50 kilometers a day in the city. Then there is a second application where people are running at about 200 kilometers or so on the highways, and that number is averaging anywhere between 120 kilometers to 180 kilometers. Therefore, if you see from both these perspectives, about a 200-kilometer range is something that people would find most usable currently under our applications. Now, one of the things that we've also noticed, and that's been the reason why vehicles like Nexon have been successful, is because for any ICE vehicle and a comparison with a likewise EV, the price differential that you need to have, or that what people are able to sort of look at today, is in the vicinity of 1.25 to 1.3x. And therefore, if you're able to configure a product which meets these basic requirements, both in the city as well as on the highway, within this price premium, then it also becomes absolutely useful and usable by the customers. Now, how do you therefore do this was the question that we had right in the front. And we at Tata Motors believe that what you do in terms of conception of the vehicle right upfront casts a long shadow in terms of how the costs eventually turn out. So in the 5-7%, 10% definition of the cost that you do right up front, that has a 70% impact or length of the cost shadow towards the end of the program. And therefore, what we did on the Tiago.ev was indeed a challenge to the fact that we named the product internally as Challenger. You kept asking about it many times. And it forced us to sort of look at the paradigms of how we would do things. And we looked at many aspects, right from the product concept, which would have later on cast a long shadow and helped us or prevented us from achieving the target that we want. As with any other engineering development, there are a lot of levers available in terms of either capacity utilization. Some of it Tata Motors benefits from because we've used an already existing platform. So in terms of capacity utilization, or we looked at alternate technologies. But we've also looked at alternate sources. And important here was to have supplier-driven ideas, platform commonality, or even the volume bundling in certain parts. Each of these aspects, and if I were to go slightly into more details, the electric vehicle offers opportunities in terms of being able to have the choice of bundling some features either within the batteries or outside of the batteries. We explored each one of these to come at the right decisions. And that's what I think has been possible or has enabled us to achieve this very exciting and, like you said, first of its kind value versus price equation that we feel going forward will help us do more optimal cars in a better way.
Right. No, absolutely, Anand. In fact, I think clearly I can go far as to say that Tata Motors is a global case study of launching the right product at the right time and at the right price. I think really it's all come together at a time when the market is still evolving. I'm sure, I would say you could get away with a few, I wouldn't say compromises, but, let's say balancing the value equation by compromising a bit on range to get the right price, as you had said, just looking at the way we use our cars. I just want to jump to the other end of the scale, which is, what Kia has launched, EV6, which is a hugely more popular model globally. They brought it to India. But Hardeep, again, these are very small volumes. You just tested the market with maybe 100 units now or 200 units. Clearly, the potential is a lot more. Obviously, this is a learning for you. But again, the topic today is on affordability. It seems that there's a different value equation given to EVs, and people do know they cost more and are willing to pay more. So did the response surprise you? Is this where it's at? And, or do you think, there is more elasticity with EVs vis-a-vis ICE engines? So just the experience you've had, which is, I know with a limited number, but obviously a huge and fantastic response so far.
So Hormazd, first of all, thank you for having me here on this panel discussion. So coming to your question, yes, it did surprise us. We were looking at volumes of about 100 units, and on day one we got 355 bookings. So it was absolutely very surprising for us, and hence we kind of requested our headquarters for better supplies. We've already delivered 200, and we are getting some more, and we will announce at the end of December how many the numbers we are doing in this category. So I will divide this, your question into two parts. I think when it comes to premium and luxury, I think the consumer is very different than when you look at probably the mass market. In the mass market, yes, I think the elasticity works, and consumer looks at today the price of an equivalent IC and electric vehicle is anywhere between 70 to odd%, which consumer finds it to be a little more. And I think as the gap will reduce between IC and EV, you will see more customers, latching onto EVs. I think people are aware of EVs, and people want to get onto that bandwagon. So far as premium and luxury is concerned, I think I think elasticity is not. People are not looking at elasticity. I think people are very, very clear whether they want to go for EV or they want to go for an IC engine. So it is a completely different space. A consumer in that segment is looking at it from a completely different perspective. He's thinking about technology. Even when you look at the acceleration figures of EV, much better in terms of environment, sustainability, etc. I think that consumer is giving far bigger value to it, and hence he's not looking at the elasticity. He's very clear what he wants to buy.
Right. And just sticking with you, Hardeep, that's quite an interesting point you made. But so what you're saying is an EV buyer, he wants an EV and he's willing to spend on it. And clearly there's not too much choice over there as well. So, price points are not defined, segments are not defined. So clearly, do you see some cross shopping also happening that, it might be a completely different, it could be an SUV, it could be a sedan, it could be anything, but the one common factor is EV, at this current point where really we're in a nascent stage and segmentation isn't there.
Yeah, true. See, if we look at, a segment which is 50 lakh plus, I think this year India will close at about anywhere between 35 to 40,000 units, which is probably very close to the peak which was done. So when you look at this segment, I think, and you try to compare it with the mass market. In mass market, we talk about maybe 5% penetration by 2025, and the market would be about 4 million units, which means about 200,000 units. And by 2030, the expectations are anywhere between 25 to 30% of the industry. And the industry would be about 5 million units, which means 25 to 30% means about 1.5 million units, which is pretty substantial. But when we look at the luxury and EV space, I think it'll grow even faster because the consumer is willing, and many of the luxury car manufacturers, they are moving more into electric. So I feel the 50 lakh plus segment probably will move at double the pace of what the mass market move at. So if the mass market is at about 25 to 30, I very easily assume that premium and luxury space would be in the range of 50% plus. So, and the consumer is, far more experimental, far more educated, and hence, the transitioning, and even those manufacturers are moving at a much faster pace. So I think that's how I feel the transition will happen.
Clearly, you're seeing 50% increase, but that's obviously off a small base. But obviously, at some point, it'll start plateauing out as well, because in the end, they are expensive vehicles. So, I mean, do you see that happening? And then do you see there will be a need for companies like yours, which I'm sure are doing, to start moving further down into more affordable segments as well, to really penetrate and get good volume in EVs?
Yeah, surely. Globally, Kia Corporation is working on 14 battery electric vehicles. We are looking at $22 billion of investment. And some of these models we are also exploring for in India. In fact, we had already shared that in 2025, we would be launching grounds up EV, which will be into the mass market, specifically made for India. We have already started work on that. And of course, we are exploring few more EVs out of this kitty of 14 battery electric vehicles, which can be suited for the Indian market. So that is the preliminary update that I can provide on that. But to answer your question, yes, we will be slowly moving in that direction. And that has been our strategy. If you look at, SUVs, we started with the Seltos, which at that point in time, the segment was very small, and it was considered to be one of the premium SUVs. And then we brought in Sonnet. In MPVs also, we brought in the Carnival first, and then we brought in the Carens. And similarly, in EVs as well, we wanted to showcase the Indian consumer, our technology with our best in the world. And, EV6 has been the European car of the year. It was amongst the finalists of the World Car of the Year. So we wanted to bring nothing but the best for the Indian consumer. And as a strategy, now we'll start moving down towards the mass market.
Right. Mr. Ramanathan, just before I jump to you, I want to just get some, let's say, comments from, Mr. Kulkarni. I just want to get your thoughts on this whole price elasticity. Obviously, with your products, a direct comparison can be made between an ICE Nexon and an EV Nexon, Tiago, T-Gods, similarly. What is your sense you are getting? I mean, is the kind of, let's say, premium people are willing to pay something that surprised you? What is the thought process? What are they ascribing value to? And do you feel that there is also on the flip side some resistance that, they are still 40, 50%, 70% more expensive than an ICE variant? And where do you think that tipping point needs to come, and how are you working towards that?
So, Hormazd, if you look at what's happened in the last couple of years, initially, the early adopters of electrification have been drawn in by the unbeatable running costs and the eco-friendliness. There are a lot of early adopters who are people passionate about doing something for the environment and making sure that their footprint is significantly better. But very quickly, as they start driving the car, they start realizing the other virtues of an electric car, which is in terms of a very smooth drive, a very vibration-free, shock-free kind of a driving experience. It is even if the car were not to be in that kind of a segment, the drive and the experience that it offers is 2 segments up. And this entire thing about the smooth drive, spirited performance, instantaneous torque availability is all something that people very quickly get used to. Now, EVs delivering this. When we started off, the payback period typically for somebody who drove about 1,500 odd kilometers, 18,000 kilometers a year, 20,000 kilometers a year was in the vicinity of roughly 24 to 36 months. Now, if you see what's happened with respect to fuel prices, they've risen almost about 20-25%. Then they were actually a little higher, and then they've scaled back a little bit. But then it's made the case even a little better when it comes to the cars that we are currently able to offer. And then beyond the early adopters, people were looking at, there was always this unspoken fear of will I have range anxiety? Will I have the ability to charge my cars wherever I need to, etc. In the past 2 years, while we have had the early successes in terms of penetrating the EV markets, we've also been going full steam along with Tata Power and setting up charging stations on highways. Also, our telematics data has helped us isolate which areas are more frequented by people, and we've been able to set up charging stations, which is now enabling people to do longer journeys without much difficulty. You have to still plan around your journey. There's no doubt about it. But people are finding how they can go around the entire journey without too much of a hassle. So I feel there is always a case where, like Hardeep said, there's a premium, super premium, top-end car with a longer range, but there are also the ability to give mobility freedom to people by providing fast chargers at dedicated locations along the highway, therefore enabling intercity distances to be done. And at the same time, because what I responded to in the beginning, the 200 kilometers odd range in a city gives you a week's long drive session. So that's how things are sort of closing in on both sides. And if you to your question about what is our actual data saying, for example, now we have launched a EV with the Nexon, which also has an ICE sibling, and the Tigor, which also has an ICE sibling. And therefore, it is fair to say that we can see indications, and the indications are that almost 25% of the bookings for the electrics or the booking interest is there to the extent of 25%. And we are actually delivering almost 17-18% of our cars that we do on the Nexon as well as on the Tigor in the electric forms. Therefore, can we extend this and say that when a wider selection of vehicles and choices become available to people, it's easy for us to do a 20% plus kind of a penetration relatively easily? I think those initial worries, initial barriers are fast fading off. And in the next few quarters, whatever residual problems are there should also get overcome. And we are actually waiting to see what happens with the Tiago.ev, because that's, as you said, it's a fantastic value cost proposition. And then because of the infrastructure that we've already got in place, it should help people have much more freedom.
Right. No, well, very interesting points, Mr. Kulkarni. And I think, clearly showing that 25% are EV. I would imagine they fundamentally come at the cost of the diesel vehicle, because that is closest in terms of price. The Nexon diesel I'm talking about, and also the fact that diesel is losing a lot of its appeal. So, I mean, would it be fair to say that's where it's happening?
We see that actually the electrics are not completely eliminating the diesels. We still do diesels, and we do diesels in reasonably good numbers, almost as much as the electric.
It's clearly grown the market.
It's grown the market. So, for example, when the Nexon EV was introduced, we were doing less than 10,000 of Nexons. Today, we do about 15,000 Nexons on a monthly basis. Yeah. So the market is expanded. There's no doubt about it. But there's also an equal number of people who would want to switch to a cleaner option and a more aspirational choice if the choice is available. That's the point.
Right. Thanks, Anand. Mr. Ramanathan, just looking from your side, again, to get the right price value equation for EVs, which are expensive today. There's a lot of testing and validation which has to take place. Obviously, there's a cost to that. So, how can testing and validation systems help OEMs kind of achieve, let's say, lower their costs or achieve the right price to value equation? Yeah, you're on mute, I think. You're on mute.
Sorry.
Yeah.
Testing and validation does add to a lot of cost to the vehicle, and big OEMs like Tata Motors and others have a very detailed program of testing and validating the vehicle over a long period of time to look at what type of warranty that they can give and what kind of performance that it comes across. But as I see today in the market, apart from some of these big OEMs, there are many startups, and these are the people who are not able to actually afford to have such kind of facilities because they don't have enough money to test and validate. And I see many people launching vehicles in the market without actually validating those products. Just to save on the cost. That's why you see issues with the performance of the vehicle here and there, breaking down and things like that. So with the testing and validation, to answer your question, you can basically optimize. For example, in one of the projects that we did, we optimized the motor capacity. So we were able to reduce the motor that we were using in that electric vehicle. And with the result that we were able to reduce the battery capacity and then again the weight of the vehicle, and we could offer a little bit bigger range for a city driving condition. As Anand had just mentioned, you don't travel very far off inside the city every day. So if you're looking at about 100 to 200 kilometer range of a vehicle, then that is good enough. So then, we reduce the cost of the vehicle by reducing the cost of the battery, because battery is today one of the major costs in an electric vehicle. So if you want to optimize the cost there, obviously, weight reduction, this helps. Right. So I think in that way, we are supporting.
Right. No, interesting point that, especially for the startups, obviously, validation and all done locally and cost effectively would make their entry point earlier. But again, coming to startups, there have been issues in terms of safety. And that's led to some pretty stringent new battery regulations, which I'd really like to have all the panelists' view on. Starting again with you, Mr. Ramanathan, we've seen that there is new norms, much tougher norms coming in. Just your thoughts on that. Clearly, for small volume players like Kia, when they're looking before they get into the mass segment, that can be a challenge just because it's not feasible sometimes for small volumes. So your thoughts on how the kind of let's say the new norms, some feel that it could deter new product introductions. Some feel that it's been designed by the OEMs were not consulted in this, and they were done by more like battery experts and others without thinking of the production challenges that they pose. So just wanted your thoughts on that.
The way we saw it when we started developing some vehicles initially last year, we were looking at AS 048, and then this new regulation came up. And this is typically looking at the fires that were coming in, and some people were killed. So the government immediately, started with this new regulation. What we saw was that the government was more particular about the safety, and when it comes to the battery, in terms of whether it is thermal effects or when it is testing it mechanically. Battery management systems, looking at the temperatures inside to make sure that you have enough protection there to look forward if the temperature is rising. I mean, some of the cars we have already tested, for example, at Tata, some of these safety measures were already in place, but there were many mushrooming. It was like a mushrooming industry. Many players across, small players buying cells from wherever they could get their hands on in China and some other places, and trying to make a pack and selling it across, putting it in their vehicles without having enough safety devices. So I think it's a welcome move, in my opinion, to have this. But on the other hand, India did not have enough testing facilities to implement this. So there were hardly a couple of facilities where we could actually go and do this testing. So that means a long queue today to get your battery certified. It's not an easy process. So supply chain gets affected immediately for many of the automobile companies. So that was there. There is a small disruption, but I think eventually after a couple of months, I think this will settle down.
Right. That's a good point. Good points Mr. Ramanathan has raised. And, maybe Hardeep, I'll start with you or go back to you on this from the OEM side, small volumes, obviously to test to the, I think the, let's say the motive is good. After all the fires, you needed a much more stringent norms and regulations, especially for the startups. As Mr. Ramanathan said, they were just getting, raw material cells from anywhere and really not giving safety too much heed. But obviously, this is across the whole industry. The rules apply to everyone. For a player like y'all, is this could it delay product introductions or, let's say, is it unviable for small volumes? How do you see the battery norms impacting, let's say, the business here for EVs as well as even price to a certain extent?
So Hormazd, that's precisely the reason why we are, we are not hurrying up into, launching our products. We are taking all those points into consideration before we start launching the products which are made for India and made in India. And which is where, while we are in 2022 and our mass market is likely to be around in 2025. So I think that gives us sufficient timelines to take care of all these regulations and make sure that because safety is at the core of our business. We don't want to hurry up into any project or launching of any car and compromise on safety. We want that anything that we launch is complying with all the regulations, and it's absolutely flawless when it hits the ground. And that we have factored in all those points during the launches of our cars, which is why you don't see immediate launches, but the launches after certain gaps. And EV6 in any case is complying with all the global regulations. It was ready, and also we wanted to test waters in India, how the consumer perception about cars is, and also launching at that price and getting success with those numbers really gives us confidence that when consumer is looking at Kia from a premium positioning perspective and is latching on to so many cars, it gives us confidence to bring in more cars. But that also puts a lot of responsibility on our shoulders, that when consumer is trusting us, we have to give nothing but the best to the consumers.
Right. So would it be fair to say that, let's say for imports or very low volume products, it kind of in a way pushes you into the direction of more, let's say, mass products with localized components, because the testing is also done locally. Is this inadvertently pushing you all more towards that direction?
So Hormazd, that has been our philosophy and strategy. I think we were probably one of the foreign players to come in India and start with a very high percentage of localization. So that remains again. It's one of the core philosophy that we work on, and since it is still another 2.5, 3 years away, we are still working out and finding solution to what can be localized and what we need to import. But the fundamental direction is that yes, when we launch, we need to maximize the localization.
Right. Anand, coming to you again, on this topic of the new battery regulations, we've seen them there, I think some 15, 16 parameters, what needs to be tested and certified, validated, right down even to the cell level. How has this impacted, let's say, product launch plans, production plans, even affordability? And as Mr. Ramanathan said, the fundamental issue seems to be, just the testing and validation capacity, and there are long queues for that, which tend to delay programs and launches.
So I would like to say, adding to what Ramanathan has already said, see, the fact that the industry was going to move from AIS 48 to AIS 038 was not something which was a sudden change. We already, all of us had more than 15 months. This was notified last year, sometime in June, July. Right. That's when everybody knew that we were going to shift to AIS 038. And so preparations would have, I presume, preparations would have begun in all earnest towards that. The second thing, Hormazd, is, and like Hardeep and Ramanathan both have also exactly reinforced that, I think on a new technology, when we are trying to set that up in a country, there will be many questions asked. So I think safety has to be paramount. It has to be a base aspect. So we can't absolutely compromise on that. And that's the way to look at it. What happened in this is, between the time that the notification came through and the date of 1st December 2022 was set up, some incidents happened. And those incidents, in fairness, made everybody sit up and take notice of how the low entry barriers for electric vehicle technology could cause trouble if not controlled or if not managed properly. And that's where I think there was a decision on part of the government to sort of accelerate and bring it forward. A consultative process was indeed followed. We were all a part of it. So the government did call for our views. There were discussions that happened. The industry was able to explain exactly how things would be difficult in certain aspects. And therefore, we see today it has been split up into two parts. There is something that has to get implemented from 1st of December. And then there is something that has been allowed to go over until the end of March as well, March 2023. So this wouldn't have happened if the government wouldn't have been in a collaborative state and saying that we want to do what is best for the industry and we want to do it consultatively. Of course, today, as we see, there are more and tighter regulations also being pushed, which we will, I presume, and I hope that we'll again have this opportunity of a consultative, collaborative work to explain what the difficulties are and move. I think overall, the direction is absolutely right. We have to move in that direction, and we have to make sure that this technology does not get tarnished because of certain aspects not being done properly or certain safety critical aspects being overlooked. So to that extent, we are absolutely in line with it. To your second question, whether there are the facilities have been stretched, even as we were going through the consultative process, it was very clear that facilities are lesser. There is no doubt about it. And but people like ARAI, ICAT, everybody jumped into the fray and they said, look, guys, we understand this is difficult, but we will make sure that we can do everything. I mean, I remember a close friend of mine in one of these places saying that we will work 36 hours a day. So that was the spirit. That was the spirit of how we wanted to get it done. In fairness, they have tried their best. In fairness, they've also said that where it is difficult, we will also take a more cognizant approach as to what is being done. Some people have benefited because they were already on a safety roadmap. Some people who needed to improve themselves have to get there. There is no doubt about it. And that's the entire way we need to look at it. This is a minor blip in an overall bigger picture. And I think we need to support it fully.
Right. No, I think it's quite clear. I think obviously safety is paramount. But it does, as you said, it does come at a certain cost. I think a cost which everyone, I mean, nothing is free in this game. So, but I think at least once, as you said, you get over this hurdle, there'll be some regular norms set. But just coming back to regulations overall. Do you see, and this is actually goes across goes across segments, including ICE as well, that regulation sometimes adds a lot to the cost. Do you think sometimes in certain areas we are a bit over-regulated, and do you think there's to be more standardization, a little bit more time given? Just wanted everyone's thoughts on that. Starting with you, Anand.
So our view is that we have to actually, I mean, Tata Motors has always stayed ahead of the regulations in terms of safety. We have always been focused. So even in terms of structural safety or anything else, we've always been ahead. And that should be the case. Why should our customers get anything different than what other customers elsewhere in the world get? Now, if there has been a steep catch up in terms of where the rest of the industry is and where we have been, then there will be a phase of accelerated development on safety or any other regulation for that matter. But I think that's the way to go through, because otherwise we keep continuing to say that we have to make only cars of a certain, and like you said earlier, there is nothing like a free lunch. So somebody else gets the hard end of the stick if we all don't move up this path. So that's how I look at it.
Right. And Hardeep, I mean, regulation is something we've been lived with. I mean, I think right from BS6 or whatever, I mean, we're shifting topic off here, but just generally regulations that's coming into the EV space now as well. But I think something the auto industry has to factor in as well as we move along, safety issues, other compliance issues, regulatory issues, which constantly keep evolving.
Hormazd, as Anand mentioned, I think, as manufacturers, we are responsible for a number of things to make sure that consumer is safe. For example, Anand spoke about structural strength. Also, in terms of airbags, probably, we made sure when we launched our currents recently, we made sure that it comes with 6 airbags. Then we made standard 6 airbags in Seltos. Our Sonnet comes with standard 4 airbags, and we will be, we are looking at that also, how quickly we can make that. So, we try to stay ahead of the curve, but there are certain regulations. For example, the rear seat belt reminder now, which has suddenly come because of certain incident. Overall regulations do put a lot of pressure in terms of costing, and we have seen, moving from BS4 to BS6, and now BS6 phase 2 coming in. I think the cost is really going. So I think somewhere we need to strike a balance because ultimately there is something called the elasticity of demand. And we have seen over the last 2 years, of course, regulations, and also because of the increase in raw material prices. And we can already see pressure. Especially, as you move towards the entry-level cars, and we are seeing that the hatchbacks are shrinking. There, the cost is pretty similar. So as a percentage of car price, it goes up significantly higher. And hence, certain segments are shrinking. But wherever the cost as a percentage of car value is not so high, they still continue to grow. So I think we need to strike a balance between what is required for the country. But as manufacturers, I think we feel responsible to give something which is required by the consumer, and we try to stay ahead of the curve.
Right. And Mr. Ramanathan, again, testing, validation, good for you, but increases the cost for OEMs. But that's one part of it. Obviously, that's going to go on. But just looking overall at EVs, they're fundamentally very reliable. I'm sure you've tested them. Less moving parts, less to go wrong with. So in a way, to the consumer, the overall running costs we know is what it is, but even overall maintenance costs would be much less than what, let's say, ICE vehicles are. So there are also benefits in terms of, let's say the overall, EV proposition in terms of from a consumer point of view. So, but of course, this testing issue, it's come into EVs now in a big way, especially with the battery norms, much needed, as everyone has said, but it's one of those things which does add to cost. And maybe, your thoughts on how some of the cost is offset by just the sheer low running costs and maintenance cost of EVs.
It's again a question of, as I said, the design. In our company, in our new startups, we are looking at launching electric vehicles at similar costs as ICE vehicles, or probably 10% higher. So that is what we expect is going to drive the demand. Yeah, testing is definitely there at ICE vehicles as well. You have more, in fact, emissions and so many other tests are there. So when it comes to an electric vehicle, you're more looking at electromagnetic interference, you're looking at noise, you're looking at, testing the motor and the battery, and the standard vehicle test in terms of gradability or acceleration, braking. Standard test is what you're looking at. So in fact, the major cost probably, if I'm going to set up a new test facility, for example, now for EV, we are looking at a complete new proving ground along with test facilities for batteries and looking at cell testing as well and motor testing. So we already established one in Bangalore. Now we are going for a bigger unit. So we see a huge demand for battery testing. So that is, but this is not something probably every OEM is going to do. So probably their vendors, there are many battery manufacturers across our, let's say, people who are buying the cells and making it into packs. So, and there are a lot of companies who are looking at BMS systems. So these are companies who are going to hire us, who are going to give us the work. So that will definitely add up to the battery cost. But I think if you are going to make it in India, looking at the FAME and other stuff that the government is going to come up with, the cost has to go down. As the volume goes up, we have to look at the costs going down. But again, dependability at this point is definitely majority is into one country. Where the cells are all coming in from.
That's right.
So that is at this point of time, for me as a manufacturer of vehicle, it's a concern because when I start producing in thousands of vehicles, I'll have supply chain issues if I don't plan it very properly, because I need that many millions of cells across in my company regularly coming inside, then testing it and validating it if I am a battery manufacturer. Yeah. Right. So as a test facility provider, yes, I think there are less facilities today in India, which is an opportunity for us to set up new facilities and get the business. But I think the cost perspective from the testing point of view is not going to be that high that the cost of the entire production is going to go up by a big way. It's only going to be a minor cost in my opinion. Yeah, end-of-line testing, yes, will increase the cost a little bit. When you're testing every single product that is manufactured, then yes, the cost will go up by a few thousands, but not in a very big way.
Right. Thanks, Mr. Ramanathan. I think clearly, on the point on cells, that's a very key issue. As you said, a lot of them coming from China still. That's where, especially LFP chemistry, where they are really strong on. But before I touch upon that, I think one important factor that's really driving the affordability, and I think we have to really give it to the government, is just a 5% GST, and the fact that even the states have pitched in, waiving of road tax and stuff like that. Anand, I think we sometimes, I don't know, we don't factor that in enough. And, could there be a time when that could even go? Because clearly once EVs reach a certain, let's say, scale, cost competitiveness, this sort of big push which we are getting in terms of, tax, which has been absolutely phenomenal, especially when you compare it with 28% plus for an ICE vehicle. It's been outstanding. I think there couldn't have been a better push. So that is really a key driver. I would say probably the biggest driver today for EV demand.
That's true. And therefore, the initiatives have always played a big role in electrification wherever you look at across the world. And it's a technology that has had to be supported significantly on account of the battery costs, which typically are between 40 and 50% of the total cost of the vehicle, whichever way you look at it. So the way that we look at it is, the government has helped, like you said, in terms of both the demand side as well as on the supply side. So on the demand side, the FAME was a landmark document, and even today it exists, because all state governments also use the same kind of document or the same acceptance criteria. So these purchase incentives, road tax exemption, registration exemption, etc., they've definitely helped drive down the cost differential between an ICE vehicle and EV in the initial phases. But also, Hormazd, we need to look at the fact that when you are trying to set up new technology, the volumes are less, and therefore it becomes a chicken and egg story, right? If you do not have visibility of the volumes, where do you invest in? And if you do not invest, how do you bring down the costs? And therefore, unless somebody kickstarts this entire thing, it really becomes extremely difficult for us to be able to say 5 or 10 years down the line that the company or the country did not do enough to sort of embark on this particular path. So the one thing that is very important is that there has been a consistency in the policies in terms of whether it is FAME which drove the demand side incentives, and now with PLI and with other incentives for batteries, etc., coming in, where you want to set up the battery making facilities internally, it also starts building up the ecosystem. And that ecosystem development over a period of time will help in being able to keep maximum content inside, and therefore drive down costs further to a point where it becomes, hopefully, we all wish for that day, hopefully that it comes down to a parity with respect to the ICE vehicles. And also, if you see, because of the emission after treatment on ICE vehicles, it's constantly, the technology cost is pushing up. Whereas with all this other incentives and interventions that the government is doing, it's all the electric vehicle costs are being pushed on. Whether it will remain at 5% over a period of 5, 7, 10 years is a matter of speculation. And I think it should come back to a more level thing, hopefully. But also, it's important to understand that in the process, we would have embarked on this path in an irreversible manner. And that's what we all intend to do. Otherwise, meeting the goals which are promised at various environmental sessions, etc., is just next to impossible.
Right. No, good points, Anand, over there. And, Hardeep, turning to you, clearly, I think you do need, let's say, government support intervention when you're trying to seed new technology, which when you don't have the scale is that much more expensive. But, you're coming into the EV market 3-4 years down the line, I guess with the assumption that certain taxation levels will still be there. We are not sure if there'll be a FAME 3. There's a good chance there won't be a FAME 3. But, just your thoughts. Are you a little concerned sometimes that, it's this tax, it's too good to be true at 5%? It's really a fantastic support the government has given. How long will it last? Is that a concern, especially that you're, let's say, investing or coming in a couple of years later. For Tata Motors, I think, it's been absolutely fantastic. They've ridden the wave of the demand and growth. And just from your point of view, obviously this must be weighing on your mind as well.
Surely, Hormazd. I think, if we look at some of the trends, I think most of the state governments, they give a lot of subsidy. Of course, central government has given, which is a big boost. Now, look at case of Mumbai. I think there was a huge subsidy in case of Mumbai, and moment, certain threshold was reached, the taxes were increased. Now, I'm just giving an example, which is very, very local. I think state governments are doing it. And as the percentage will go up, it is fair to assume that that is a loss for government. If let's say we are talking about 30% in 2030, to have a 5% tax on 30% of the vehicles, it's difficult to say that government will not increase, because that's going to be a big loss for the exchequer. So I think as the volumes will increase and the government will see how much is the overall GST kitty which they're generating out of automotive, what percentage is it contributing to the overall direct and indirect taxes and movement, they will see there is a certain percentage fall in that. I'm sure they will look at tweaking it. But yes, it does weigh on our mind when we are moving towards it, because we are coming another, as you said, 2 to 3 years down the line, and we hope that by that time, since the penetration is not going to be more than 5%, we don't see it changing so quickly. But as it starts moving towards 20% plus, I'm sure government will look at it, considering what is the total loss which they are incurring on the GST collection.
Yeah. Right. Mr. Ramanathan, obviously this is not quite in your sphere as being an OEM, but, just your thoughts on, let's say, clearly, I think taxation, whether it's at the state level, they're given a lot of benefits at the central level. It's really boosted EV demand, much better than we thought. In fact, the growth for many has been much faster than we thought, which again might get someone to say, Hardeep said, that are we losing too much GST, or the GST kitty? Are we losing over there? So, do you think that going forward, OEMs have to kind of, let's say, plan for, let's say, higher levels of taxation, which again obviously hit the margins, and again find ways to keep lowering costs more and more?
If you compare it with other countries, yes. If you look at other countries, as soon as fuel cells have come in, and there are other technologies that are coming in, so their governments have already started pushing for those technologies. Probably in India as well, hydrogen, fuel cells, and alternate fuels are areas where the government is going to focus on. So once this attains a certain value, a certain level, probably subsidies will be taken up, and probably once the infrastructure is ready, and that is something that is going. Once it comes across, probably the percentages of EV might go up, and once that happens, probably then the government will look at alternatives as well. It's about what are you going to promote in the future, looking at battery storage and basically energy storage, and looking at the powertrain there, the motor. And once India is able to manufacture many of these in-house, and this market booms up, the costs go down. Once it becomes affordable, let's say, it will come, the taxes will go up. You have to plan for that.
Right. Well, I think, we are running out of time. I mean, it's amazing how quickly time has grown, but we've had a fantastic session, and I can gauge that by the number of questions that have just absolutely poured in. Very, very difficult to take all of them. There's been a huge interest in this session. So I thought I would take one question, because it does relate to cost and very pertinently to the cell. This is from Chaitanya Bala, who's tuned in. His question is the concern and impact of rising cell costs, and how companies would react to this, and the impact it would have on the overall vehicle. So Anand, I'd like to turn to you, because clearly this is an issue, but it goes back to the point which Ramanathan made, that at the end of the day, we finally got to start producing the cells in India, which could be the game changer as far as costs go, and maybe even mitigate, let's say, rising cell costs, which again is driven by geopolitics. It's not very stable. It's volatile. So are these also concerns of yours from keeping the affordability in check?
Yeah, so it's a highly involved question. I'll try and keep it as brief as possible, Hormazd. I know we are running out of time, but from a battery perspective, you need to look at cell cost versus non-cell cost, and cell costs have indeed been on a historic high because they fell for the best part of the decade at a very rapid pace, and then over the last 2 years, we've seen them, particularly the lithium carbonate values, having grown 10 times in certain cases, which has had a knockdown effect on the value of or the price of the cells in the market, almost to the extent of 30%, and something that constitutes almost 50% of the value of the vehicle, it's going to have an effect. So we already see this to be sort of plateauing out a little bit, but there is it would be akin to speculation to say whether we will improve from here or not. I think one of the things that we as a company tend to do is focus on efficiency, focus on right sizing of the batteries, and focus on being able to provide the right solutions to our people rather than just go behind an arms race of whether my battery is bigger than yours kind of a thing. So it is difficult times right now. We may not have the ability to pass on everything into the market. And therefore, as I said, we continue to work on other aspects as well. Things to watch out for, yeah.
Right. Hardeep, we've still got a few minutes left. So again, on the concerns of just generally rising costs, especially of raw materials. And, is there a way of adding value by, the other stuff, which is the onboard tech, which somehow fits so well with EVs? They just lend themselves naturally to EVs. So more ADAS, more connectivity. Is this one way of, let's say, bundling more value and, making EVs a more juicier proposition, other than obviously the EV part of it?
Yes, I think, EV is already aspirational. And I think with the connectivity and all the stuff which is getting added on top of EV, I think it is going to become more aspirational. ADAS will bring another angle to it. And I think, one is purely a rational perspective to look at it when the consumer buys an EV. But the second one is a little more emotional and even also an angle of responsibility, because there are a lot of buyers today who have the choice of IC, but they are moving at a cost which is 7 to 80% more, and the break-even time period is much higher than probably what we would expect it to be, especially in future when the cost differential is only, let's say, about 30 to 40%. But there are still people moving in that direction, and that's purely based on this a little bit of emotional and also I would say the corporate social responsibility perspective, where people feel that I want to contribute to it. So I think if we look at it from that perspective and make consumer more aware, I think we will certainly see more people latching onto it, irrespective of whether we are able to achieve those costs in the short term. Because we have seen, because when you look at the graphs a few years back, and the battery cost projections were coming down significantly, and then suddenly we saw that curve moving up. So sometimes these factors are not in our favor. So probably we need to look more at a consumer education so that they continue to buy electric vehicles at a slightly more longer break-even period. I think that's the way.
Right. Thanks, Hardeep. I think you've summed it up quite well. I think clearly we know that there are huge cost challenges still. We are dependent a lot on government policies to keep the price in check, make them affordable for OEMs. Clearly, adding more value, as you said, is one way there. And clearly, EVs are more aspirational, so they want more tech in it and are willing to pay for it. But been a very interesting session. I'd like to thank all of you all for joining us, and appreciate your time. And thank you very much. And I will hand it back to Mayank. Thanks, everyone.
Thank you.
Thank you. Thank you, Hormazd. Thanks, Mike.
Thank you. Thank you.
Thank you very much, Hormazd, and thank you everybody for being part of that lovely panel discussion. and rightly so, on decoding the EV affordability challenge. And with that, we would now like to move to the next breakout presentation on the topic StarFlam X Protect Polyamide 66 as a solution for EV batteries thermal runaway protection. And to give this presentation, I would like to invite Mr. Vineet Kapila, who is the e-mobility global strategic market leader, Ascent Performance Materials. Mr. Kapila oversees market strategy, managing new product and technology introductions, and aligning the company's business strategy with evolving e-mobility trends across light, commercial, and 2- and 3-wheeler segments. He started his career at the Ford Motor Company and holds a master's degree in plastics engineering and a bachelor's in electrical engineering from the University of Massachusetts, Lowell. Mr. Kapila owns 2 patents to his name and has served on the board as well as the president of Society of Plastics Engineers, Detroit section. Over to you, Mr. Kapila.
Good morning, everyone. Thank you for that introduction. On behalf of Ascent Performance Materials, I would also like to extend a thank you to the conference committee for the opportunity today to present at Autocar's EV Forum virtual conference. Today's presentation is titled StarFlam X Protect, a polyamide 66 or a nylon 66 solution for EV batteries thermal runaway protection. The StarFlam X Protect brand fits within our E-Range family of solutions. The E-Range family, as we call it, is a family of products that are being specifically developed with e-mobility needs in mind. Furthermore, as we wrap up the presentation before the Q&A session, I will also briefly share a bit about our company Ascent Performance Materials and our growing footprint in the India market. So before we get started into the content for StarFlam X Protect, let's take a step back in terms of what we're seeing as a global trend in mobility. Certainly, we've seen a strong push towards electrification or zero-emission vehicles happening, and it's happening rather rapidly across the globe with not only established OEMs but a plethora of startup entries. And the impact is being felt across all vehicle segments, as you see here in this slide: Class 1. Type 2 vehicles, which is primarily your 2-wheeler space. In the Class 2 to 3 space, we're talking light vehicles, especially when you look at pickup trucks, crossovers, and so forth. And there's a lot of new entries that we've seen in this place in the last just 2-3 years. You have startups like Rivian, Lucid in North America. Then in the China space, you have Neo and Xpeng and so forth that have come in. And then, of course, we have the variety of established players, Volkswagen, General Motors, Ford, and so forth, that are starting to accelerate electrification as part of their platforms. So again, policy mandates across the globe are helping make this a stronger push towards adoption of electrification. But certainly we also see the aspect of the business model piece, which new business models are being created whereby companies that are partnering, collaborating together. For example, Amazon partnered with Rivian for last mile delivery vehicles. Along the same path, you have General Motors that also created a separate business unit called BrightDrop, again, last mile delivery vehicles. In the US market, certainly robo-taxis have started to take off. Again, same thing. The Amazon folks have introduced Zoox as part of it. But even if you look beyond that, in terms of the next wave, if you look at Class 4 to 8 vehicles, there's a strong push towards getting electrification in place. For school buses, there's a lot of regulatory push towards that, as well as government incentives being provided. And then certainly we also see potential for hydrogen or fuel cell vehicles coming into the commercial vehicle space. Presently, the global vehicle production is still very much ICE heavy, internally combustible engine, roughly about 75%, and the remaining 25% or so is split between hybrids and full battery electric vehicles. And primarily that space is still dominated by hybrids. But as we see further out, the picture becomes a lot clearer as the adoption rate for battery electric vehicles continues to grow quickly over this decade. And again, it's going to be driven by transition to clean energy, zero emission. It'll be rapid, as well as the landscape is going to be changing across all different regions. So roughly 70% of the global light vehicle production is estimated by 2030 is going to be electrified. And then, of course, as we see, there's going to be a significant downward trend in terms of not only vehicles, but investment from the OEM community for the ICE side of it. So as part of the sea change, India is also ramping up the BEV adoption in the light vehicle space, as we see in the data on the right-hand side. although India is starting off with a much smaller adoption rate at this point in time, the rapid growth will start to happen, as we go towards the latter part of this decade. Even at the COP26 summit this year, the Indian government committed to reaching roughly about 30% private vehicles to be electrified by 2030. That's a pretty good aspirational growth rate when you look at it from the overall amount of millions of units that are sold. We're talking somewhere in the neighborhood of about 10 million vehicles. So while a major part of the growth, of course, in India market is still going to be electrified two-wheelers, the electrified light vehicle space, class 2-3 segment, does look very attractive in the coming future. To close out the point in this slide, what we're talking about is, India is not starting from scratch. Neither is the technology towards adoption of electrification. They are there to ensure rapid expansion happens safely and without losing consumer confidence, which is obviously going to be the key thing for future. Lightweight, comfort, and safety are not necessarily new trends in automotive. And as we look at it, they've been around as megatrend decades ago. However, when we start thinking about e-mobility space, it does present a new set of challenges and rather unique. One of the bigger challenges in e-mobility is as electric vehicle design and manufacturing has come along with the adoption of more skateboard vehicle architecture, the multiplication of types of materials being used in the construction of powertrain has become much more complex. You have combination of metals, plastics, composites, adhesives that need to all come together in order to deliver vehicles that perform safely, deliver efficient thermal management, also provide reduced NVH. As a partner to the industry, our e-mobility team has bucketed these challenges into 3 specific categories, and that kind of aligns with our product portfolio and our core competencies as well. The first one is safe power structure. We're talking primarily about, for example, EV batteries, or anything that's high voltage related that requires thermal protection, especially when we look at it from the industry standpoint. The industry is still grappling through challenges to figure out how much thermal runaway has an impact and how much escape time is required for the consumer to be able to feel safe in their electric vehicle. So StarFlame product portfolio from our overall Ascend portfolio fits into this category. When it comes to reliable thermal management, our offering is Hydura, long-chain polyamides. And finally, in terms of secure and comfortable ride, addressing NVH type issues, is Viadyne PA66 and 6. So now let's get into our StarFlame XProtect technology. As I mentioned earlier, it is technology that provides protection, particularly in EV batteries, where you have thermal runaway concerns. So when we look at regulatory side, 5 minutes is being accepted at this point in time as the industry standard for thermal runaway, whereby an occupant can escape out of the vehicle. But in other cases, OEMs and the industry is now pushing towards up to 30 minutes, even more. And that puts a significant challenge in terms of the materials and usage and how do you bring about the safety within the EV assembly. But even beyond just the technical aspect of thermal runaway, there's the reputational aspect. Certainly from a consumer confidence standpoint, we don't want to be having a situation whereby materials used in that EV assembly are not able to meet up or keep up with the thermal requirements as they continue to increase. So to that point, we have at Ascend conducted a testing from flame testing, and let me walk you through that video next. Ascend has tested 3 materials in the power plant fire penetration test using a 1.4 kilowatt burner with a flame calibrated to 1100 C temperature, an automotive grade aluminum alloy, a standard flame retardant PA66 with glass fiber reinforcement, and finally our StarFlame XProtect, also a flame retardant and glass fiber reinforced PA66. All samples had the same thickness of 3 millimeters, and the flame was applied onto a surface area 10 inches by 10 inches. The standard flame retardant PA66 in the middle begins to melt around the 2 minutes and 22 second mark, and the plaque is breached. The remaining structure of char and glass fibers is a porous build that allows direct sight to the flame behind it, as you see. At about the 3 minute mark, the aluminum sample on the left shows signs of melting. As the melt follows gravity, only a thin skin of aluminum remains behind and is breached at around the 4 minutes and 15 seconds into the flame test, making space for the flame reaching the other side of the plaque until the burner is turned off. Starflame X-Protect plaque on the right withstands the fire exposure. It blocks the fire and in addition keeps the temperature on the backside very low due to its insulation properties. Starflame X-Protect holds its structure with no breach through the entire test up to the 15-minute mark. Per safety protocol of the laboratory, the burner at this point had to be turned off. Based on this performance, with no breach at 15 minutes, Starflame X-Protect can be considered fireproof. Starflame X-Protect is an ideal material in this case then for use in electric vehicles where components require ability to withstand thermal runaway event. In battery pack assemblies, these components include high voltage connectors, conductors, barriers between compartments or the battery pack, or even enclosures for battery modules and packs. The material with its demonstrated insulated properties can also help shield passenger compartments or driver cabins against incoming fire. So in summary, Starflame X-Protect helps contain the hazard of a thermal runaway and thus able to meet the requirements of standards like GBT 38031, which currently require 5 minutes escape time for vehicle occupants. So now let's look at some of the key properties of Starflame X-Protect technology. Starting with the graph on the left, it illustrates that Starflame X-Protect material does not turn into a liquid at the original melting point, which is around the 260 C mark. Now, comparing this to the standard PA66 material, as you see here, this transition occurs, below 260 C. So the significance of this graph is that while the standard PA66 material loses its mechanical properties at its melting point, as we saw also in the failure of the plaque in the flame testing video earlier, the Starflame X-Protect technology allows the material to be able to maintain the mechanical properties past its melting point. So this becomes even more important of an element in applications that are being used in EV batteries, where high temperature and thermal runaway conditions are an extreme concern. So in the case of Starflame X-Protect technology, despite the fact that the material is exposed to extremely high temperatures, we were talking in the order of 1100 C or so, while there is a loss of mechanical properties, the overall structural integrity remains relatively intact. So again, it's providing protection. This was seen in the flame-tested sample as well, as we saw in the video earlier, where at the end of 15 minutes, despite the fact that there was burn and charring on one side of the plaque, the overall plaque was not compromised with the flame penetrating through. So the graph in the center shows that X-Protect technology also provides better retention dielectric strength throughout the heat aging process, which is shown here in the number of hours. So as you see in the results here in the red line that's represented here, the PA66 without the X-Protect technology. Now, whereas the blue represents various materials that we've created with the X-Protect technology, and the performance is significantly better. So the benefit of the X-Protect technology in a high voltage application is twofold. One, providing better insulation retention over a period of over a lifetime of the application. Again, we talk about battery assemblies, as well as maintain insulation in the case of thermal runaway situation. So it kind of covers both areas. Finally, the graph on the right shows that PA66 X-Protect technology also offers much better creep resistance, almost on the order of magnitude of 2x than standard PA66. So this creep resistance testing is at 100 C at about 15 megapascal applied stress level. So plastic creep resistance is an important aspect to consider in battery assembly for components that are exposed to high continuous loads. So this could include, again, battery covers, trays, and as well as other structural components. So let's summarize, what we've been able to show you thus far with regards to Starflame X-Protect technology. So flame retardant is an important aspect of a material or technology to help prevent fire penetration. Again, is an important aspect in terms of protection for the occupant in a thermal runaway situation. And high thermal performance of a material technology is also important to consider in terms of plastics materials being used, because the material doesn't melt or drip above its melting point, therefore, again, enabling you to have higher performance in applications. Particularly in thermal runaway situations, you want to be able to have materials that are being used that can also offer added protection Therefore, if comparing it to aluminum, for example, where the breach was occurring at about 4 minutes, here's a plastic solution that's able to withstand up to 15 minutes. So essentially giving you the performance where in cases where we're talking about moving from 5 minutes escape time in a vehicle in a thermal runaway event to up to 30 minutes or potentially even more in the future. On the technical side, if you look at it, the ductility and the impact of the material, the thermoplastic material, is going to be better than thermoset materials such as bulk molded compound, sheet molded compound type materials. Another aspect to consider for the StarFlame XProtect technology is, again, based on thermoplastic technology, it's recyclable. So when we start thinking in the big picture, and if you look at components that are being used in EV batteries, having a view of sustainability, if you want to be able to have materials that can be potentially recycled in the future, as opposed to coming out of the end of life of the vehicle and the battery and winding up in a landfill somewhere. Overall, as I highlighted in the earlier slide, better creep resistance to high temperature is an important aspect. Overall, chemical resistance, again, you have multiple materials that are being used inside of a battery assembly. So certainly chemical resistance becomes an important property, and polyamide-based solution here offers that performance. And finally, you look at reduced moisture absorption. So while we're looking at the battery as a sealed unit, certainly the electric vehicles are going to be put through challenges across various environmental conditions, from dry to high humidity to cold, extreme heat, and so forth. So the ability for the material to be able to have reduced moisture absorption allows it to perform for a longer period of time. So now let's take a look at where the application fit could be for StarFlame XProtect technology. There are several critical applications inside the battery assembly that need to sustain thermal runaway. Again, the whole goal that we've talked about here is to allow occupants in a vehicle in a catastrophic situation adequate time to escape. The top row shows electrical high voltage insulation components. So you're talking about insulators, fuse holders, cover caps, and bus bars. Again, these are all part of the high voltage environment within a battery assembly, and of course require flame retardancy in the application space. Moving on the bottom left-hand side, you have battery modules and barriers and housings. Again, when a fire event happens or a thermal runaway event happens from the cell, it starts to propagate through the modules, and then it'll start to carry over from one module to the other. So StarFlame XProtect technology is part of the barriers, can allow adequate time, again, for the occupants to escape, of course, as well as slow down the propagation of the flame that's starting to expand through the EV battery assembly. Another important aspect for us to recognize is during a thermal runaway event, we want to be able to mitigate the hot gases. So thermal management, as we've talked about, becomes an important piece. So to that end, you see in battery assemblies, battery vents. Again, the whole idea here is to push the gases into the non-critical areas, but certainly the usage of XProtect technology can come into play in these battery vents, whereby it allows, because these are being exposed to high temperature and hot gases, can be able to withstand the temperatures that we've talked about up to 1100 C. And finally, as you look at on the far right-hand side, we've got the whole battery assembly pack and then trays and so forth. Again, these require same thermal protection. They serve as the final protection in a thermal runaway event for the occupants. Therefore, ability to either design them from materials that can be able to withstand flame for a longer period of time, or the materials can be used as an inner liner to the system, whereby it allows you the added time during a catastrophic event. So in summary, what we're trying to say here is that XProtect technology combines the benefits of thermoplastics material from design freedom, manufacturability, as well as delivering high thermal barrier protection in critical applications, particularly as we've talked about here in the battery assembly. And then the material benefits can help achieve these industry targets for safety, as we've talked about, weight, which equates to range. Certainly, if you have a battery enclosure or cover that's made out of aluminum, but can be now redesigned using a thermoplastic solution like this, it offers the added benefit of weight reduction here, which again translates to range. And then overall, as we've talked about, also long-term system performance. So that kind of wraps up the overall performance and technology that we shared with you for StarFlame XProtect. Let me kind of walk you through the overall view of Ascend Performance Materials. So give you a perspective as to who Ascend Performance Materials is. We're a fully integrated material solution provider. We have world-class manufacturing facilities in North America, Europe, and Asia. We're the largest fully integrated producer of polyamide 6,6 resin, or nylon 6,6 as we talked about. It dates back roughly 7 decades, so there's a long history of being able to produce, product and technologies to that end. Our global headquarters are in Houston, Texas in the US, and we have regional offices in Belgium and China. The global automotive team, where I'm located also, is based out of Detroit, Michigan, where we have not only the traditional team that manages the ICE side of the business, but we also have the team that manages or helps manage the e-mobility side of it. And overall, globally, we have roughly about 3,000 employees. Also want to highlight here our growth in terms of manufacturing footprint that's been taking place globally, including more recently India. So on this slide, what you see is on the left-hand side, FPL Group has been formulating engineering plastic compounds locally in India since the early 90s. Since 2011, they've had a partnership with a company called Eurostar Engineering Plastics to manufacturing under the license of Starflam product line, which I've talked about earlier in this presentation under the X-Protect as well. And then more recently, Ascend acquired Eurostar Engineering Plastics. And then in 2022, we completed the acquisition of FBL Compounding Division in Chennai, India. So now that gives us the local footprint to be able to produce products the likes of Starflam X-Protect in India to be able to service the needs of our automotive and e-mobility customers. In addition to having local manufacturing in India, we also have an extensive network for local stocking solutions. Again, the whole goal here is to be able to have reliable supply and best-in-class lead times. So working through our team in India, we're able to have coverage across these major cities and regions to be able to service our customers' needs, be it for automotive or e-mobility in the future. So this concludes our presentation for today. Thank you very much for your time.
Thank you very much, Mr. Kapila, for that detailed presentation. And I would also like to invite Ms. Rashmi from your team to just take a couple of questions which we're getting from the audience before we move to the next interview, which is going to be the final session of this day. So, Mr. Kapila, you mentioned about, this, the particular Starflam X-Protect material. So just, we've been discussing through the day, how it is getting very difficult for the industry to sort of meet the customer's expectation in terms of, the pricing of these EVs. It is still on the higher side. So when they're still going to, use these kind of solutions to prevent fires in batteries. So from a localization perspective, if you could just give us a brief idea about, have you been able to localize these materials in the country and what sort of costing are OEMs sort of looking at?
Yeah, good question. So from our perspective, we're in the process of localizing it. For India, as I mentioned in the presentation, we're already localized here in the US as well as in China. So certainly, as electrification continues to grow, these types of solutions become more of an interest to the OEM community. Again, the point here that the presentation is talking about is to look at alternative solutions. So I think one of the presenters earlier talked about range anxiety being still top of mind as far as OEMs are looking at. So cost, weight, range, they all sort of tie in together. Certainly from a system perspective, one would have to look at it and say, okay, what is the cost of the safety that I'm able to provide to the customer? So as consumers, push the requirements towards having, greater need for having longer escape time. And certainly that's regulatory driven and so forth, cost will sort of become more of an important aspect as well. In delivering these solutions. So yeah, we continue to work with our customers, just find ways that we can enable it as a system approach. So it's not a silver bullet by any means to say that this is the solution and you completely replace, let's say, any type of ferrous-based solution, which is, let's say, steel or aluminum. But in combination, the system approach is probably more suited to looking at it from a different lens as far as how do you achieve a system that can now deliver lighter weight versus what the incumbent solution is, but at the cost parity or perhaps even cost savings.
You mentioned about regulations in your in your answer just now. So now we're also seeing these new battery norms being introduced in India. So with that, are you seeing more engagement between OEMs who are sort of now approaching Ascent for these material requirements? And going forward, are you also seeing some of these newer companies, the emerging startups, also sort of approaching you for these fire retardant solutions?
Yeah, absolutely. We just had the battery conference took place in September in Detroit, and again, the need is arising from every level. Certainly 5 minutes is there, but when you start thinking about how much is 5 minutes in a catastrophic situation in a vehicle where you have either, the occupants have to find a way to escape if your door is jammed. So OEMs are now definitely pushing more and more towards 30 minutes. More recently, we had heard at the battery conference that the regulation in China is going to push towards 40 minutes. Now, as you see, in a thermal runaway event, you don't have much of a time as far as how quickly the fire propagates and it melts through aluminum structure and so forth. So in essence, everyone is looking to find ways to, in a cost-effective manner, achieve or be able to buy time. Essentially, that's what you're buying. So the cost issue, I think, starts to get to a point where you're saying, okay, well, fine. Am I able to save 10%? Well, I can't deliver the 30 minutes. So if the regulatory tailwinds are going to push everything towards saying, hey, we have to have global alignment towards OEMs saying, hey, 30 minutes or more, certainly that's going to put a huge pressure as far as achieving the performance. And weight adds a negative value, so to speak, towards the range aspect of it. So I think all of these things will have to go hand in hand. Yes, there's a lot of interest coming in for this product.
Sure. Mr. Kapila, I'm sorry, we've completely run out of time for this presentation. So thank you so much for answering those questions for us. And we look forward to see you once again. Thank you.
Okay, thank you.
Thank you, Mr. Rashmi. And with that, I would now request Hormazd to please take it further with Mr. Goel for the interview session. Sorry for the delay on this. Yeah.
Thank you, Mayank, and hello, Mr. Goel. A pleasure to have you. Sorry for the delay, and thanks very much for being part of the last session. So we have with us Mr. Arvind Goel, who's the Managing Director and CEO of Tata AutoComp. Pleasure to have you. Mr. Goel, I think, we'd love to hear from you, your thoughts, especially on critical supply chain issues, which are really transforming the EV industry, but also the biggest challenge for us, especially in terms of affordability, especially, in terms of fundamental demand and supply. And even at the tier 2 and tier 3 level, where there are the biggest challenges in terms of localizing. So just to open up, supply chain, is that one of the biggest challenges for, let's say, having the EVs at the scale that we would like them to in India?
Yeah, thanks. Certainly, supply chain is one of the major issues. And basically, whatever said and done, most of the parts are still coming out of China.
Right.
And China has developed the whole EV ecosystem in the last 15 years, and they are much ahead than any other country in the world. So if you have to buy cells for making a battery pack, there are a few companies in Korea and Japan, but not having so much of capacities either. So ultimately, you have to go to China to buy those cells. And the demand in China itself was higher because they continued the incentives for another 1 year, which was supposed to get over. So getting cells is one issue. Second is the complete battery management system because of the chip shortages all over the world. These are the two major items, but in any case, there are many other items into the whole EV systems. You have inverters, and then you again need semiconductors there. Then you have 3-in-1 for passenger cars, the onboard charger, DC-DC converters, again, the chip shortages. So chip shortages and too much dependence on China. There are issues of COVID, lockdowns, then issues of sea shipments where the ships had got stuck, due to the host of other issues. Then you depend on air freights, and then all this, the supply chain issues are there. But it is slowly getting under control, but we still have lockdowns on and off in certain parts of China, which can certainly derail your supply chain.
And, Mr. Goel, just to understand in terms of, we've got the PLI scheme, which is in a way to kind of, let's say, promote more local production. But on the ACC side, there have not been too many takers for this. Let's say the big players haven't come into real cell manufacturing. I mean, do you think something more needs to be done? I know that there are talks of people coming into cell manufacturing. I think, the Tata Group, Tata Chem are looking themselves, but maybe not under the PLI. So, for ACC, it doesn't seem to have really attracted too many, let's say, players for this.
Yeah, the PLI scheme, because certainly as Tata AutoComp, we are not looking at cell manufacturing. It's within the Tata Group ecosystem, but not within Tata AutoComp. So difficult for me to answer that. But given to understand that the PLI scheme says for advanced chemistries and the standard cells which are produced today with NMC or LFP, those chemistries are not included into the scheme. And, they say there will be amendments to the scheme, etc. But I have not fully studied. This is what I have heard. But also the investment sizes are very, very large. Otherwise, you will still be not cost effective unless you have a very large volume.
Right.
And you cannot be just be cost effective from the point by increasing custom duties for people importing. You have to be, if neutrally, you should be able to match those or do better than those pricing, then volume would play a very major role. And second is, India has no mines for lithium or nickel or cobalt. And so you have to have tie-up with those mining companies. And if the large cell manufacturers in China have tied up with very, very large volumes, what sort of pricing will you get for your volumes will also play a role. So I think people have worked around it. I'm sure Tata Group would announce very soon. They are, I know they are working with, connecting all the dots. And I hope few other large players should also announce. And government should relook at what sort of incentive schemes they can give for the cell manufacturing.
Right. But it seems that before, cell manufacturing is one thing, but the sense I get from you is securing the raw materials is possibly the biggest challenge. We are far behind in that. All the kind of, let's say, capacity seems to have been mopped up largely by China. Would it be fair to say that really is one of the big challenges? I mean, for us, even as a nation, since we don't have...
Fortunately, the lithium is available in Canada. It is available in Australia. Certainly in the South American countries.
No, what I meant is that, at a competitive price.
Yeah, we should be able to, that's what one has to find out. China certainly produces their own lithium and they also import.
Right.
So if we are able to import from these countries at a reasonable price, I think it will make a huge difference. But I think everybody is trying to tie up to raw material sources. And also, there will be a lot of lithium into recycling, which will come into both these batteries and the mobile phone batteries and so many where the lithium batteries are used. I think once the setup gets created for a circular economy, that also will help. But that's a more long-term help than a short-term basis.
Right. And, you talked about volumes and fundamentally, just coming to the issue of scale. It's a bit of a chicken and egg situation also. Clearly, our EV market is very small, is very nascent, growing very fast, but very, very subscale. Is that also the biggest challenge, or do you think people, should be investing now in deep localization, just assuming that the volumes will eventually come?
Certainly, I don't think there is any choice but to do a deep localization.
Right.
And that is why initially support from the government is required, because you are doing a deep localization and the volumes come, say, 4 or 5 years down the line. So, but if you don't do deep localization, I don't think one can start anywhere.
Right.
Because then you're far more ineffective on the cost side.
Right. But, I think I'm talking specifically tier 2 and tier 3, where really China has a whole grip on those components. Do you think that to kind of, let's say, get to that level, what would it take? Because clearly that, as you said, they have got a huge head start over us of about 15 years.
No, I think that way, where people in India are quite innovative in such development. I think in a couple of years, people will be able to tie up a lot of this stuff, not only for the battery pack, but also for the motor, inverter, reducer. I think that would happen. But suppose you 100% localize the motor, where will you get the magnets from?
Right, exactly.
Because it's a rare earth items, and again, you are back to dependent on China.
Right.
So I would say, if you look for motor, for example, I think other than magnet, you can localize everything in a period of 2 years.
Right.
Reducer, India certainly have experience in making gears, etc. Okay, you need more ground gears, you can localize. Inverters, India certainly has the strength of software engineering, but they do not have so much of data of the vehicle per se. Because you also need to constantly, with the artificial intelligence, get the data of the vehicles, feedback into your system, keep improving. So that will certainly take time, but that can be localized. Chips, again, are not made in India, so you are dependent on chips. And same way on the battery, I think cells, people should be able to localize, say, I don't know what is the project timelines within even the Tata Group itself, but my gut feeling, it's 2 years would take if you start a project and localize the cells. But again, you are dependent on the fundamental raw material.
Right.
Everything else of the battery pack can be localized. And within Tata AutoComp itself, we are localizing everything of the battery pack other than the cells.
Right. And so again, clearly, as you said, it comes back to raw material challenges. But, just looking at, the EV market in India and the way it's grown, has that taken you by surprise? I mean, the pace of adoption seems to have, been much faster than we thought. And just to understand, from your point, does this mean you have to speed up the pace of investment and development as well? And just your thoughts on how the market is going to pan out in the next in the coming decade.
I know, fortunately for us, our group chairman always believed that EV is the right direction for the nation and the market will grow fast enough. So we just went ahead with whatever he said. And fortunately, Tata Motor did a good job on their EV, and they have 85% passenger car EV market share today. But, whatever said and done, the EV for the bus market, EV for the passenger car market, and EV for larger trucks, if at all it comes through or it goes to hydrogen route, also Tata Motors are planning, needs a lot of support from the government. Because whatever said and done, unless it is economically viable to a person, he is not going to buy your vehicle. Leave aside certain amount of people who want to be eco-friendly and things like that. It's more for but 95% of the population, whoever buys, they want economics to work for him. So economics for the passenger car works only if there is enough support from the government, like GST is 5%, there is a FAME scheme is there, then the state government incentives are there. With that, it is And if you are driving a lot of miles or kilometers, then it is making some sense. Otherwise, it has to first make economic sense. Tata Motors' new vehicles are also coming at a low cost. So it has to be economical viability. As far as buses are concerned, without the government support, no one will buy a single bus.
Right.
Because it's not viable otherwise.
Right.
But the two-wheeler industry, the three-wheeler industry is viable in the electric vehicle as soon as the infrastructure is fully developed. But it will make economic sense for a person to buy.
Right.
If there is driving reasonable amount of kilometers. Similarly, a small commercial vehicle will make an economic viability once it is fully debugged and start producing and start selling, like the Tata Motor Ace type of vehicle. It makes economic sense for a person.
Right.
So it is both. We have to look at volumes and also certain volumes with the support of the government. Certain volumes can come without their support. So mix and match, you have to work.
Yeah. So, Mr. Goel, you talked about government support and you listed everything that they've done. And frankly, they've done, actually, I would say a phenomenal job. As you rightly said, 5% GST, subsidies from state governments, the FAME policies. But what more needs to be done? I mean, they've done, even on the manufacturing side, PLIs for focus towards EVs and batteries. What more do you think needs to be done to really get that scale which you need?
There is some more support on the engineering side. So much R&D expense are there. I think CI has already given their wish list to the government on how the R&D on these advanced technologies to be treated in their books. That can help. And also, as I said, some more support on the cell manufacturing. Because if it is, the raw material has to be imported and then you have to compete on the volumes with the Chinese makers, then you need a far bigger incentives there. And certainly, large companies are coming forward to make an investment and do these projects. But I think if government takes an additional step there, I think these things would move much faster. You are on mute.
Yeah, sorry, I'm on mute. Yeah. So that's interesting. What you're saying is, especially on the cell side, which really seems to be the thorny issue from a lot of things, is we are quite honestly behind the curve over there. Other markets seem to have raced ahead, secured raw materials. They've got a plan. They're actually put these massive capacities of battery cell units. So to catch up, you think that's really where government needs to focus and really support local industries so that we are competitive globally.
Yeah.
Right. And, just to understand.
But also the volumes will come in. Sorry to interrupt. The volumes will also come in because with so much thrust from the government on renewable energy.
Right.
And with such large solar, energy will come in. So their storages are all from the cells, the battery packs. So, the cell consumption. So it's volumes will come in according to me. It's just 3-4 years is the trouble time, but the volumes will be there.
And just to understand, Mr. Goel, talking about volumes, obviously there are a lot of projections. We can see a horizon of 24, 25. A lot of EV players are coming in. You are supplying to some other than Tata Motors, we are aware of. What is your sense of the market projection? I mean, how rapidly do you think the market is growing? And, everyone's looking at a 2030 horizon. Just looking at your thoughts, for the rest of the decade, how do you see the EV growth in the Indian market?
See, as far as the passenger car is concerned, my thought process is that it will be around, say, 25% or so by 2030.
And 25% of how big a market? Would you say around 7 million?
So 2030, the market should be say around 6 million vehicles. And there are figures, people are giving up 7 million also. So anywhere between 5 to 7. So 25% of that should be electric. Specifically for companies who are far more focused on electric, as a statement from Tata Motors, which has come in, they are targeting to be 40% of electric by that time. So
Right.
company to company, it may vary.
Right. So that is quite a large volume, and clearly there are hurdles to achieving that volume and still from the supply chain. So, but you feel that there could be steps taken to mitigate these challenges, what you all have said. I mean, it's still a long way off, but I think to ramp up to that, volume and scale, given where we are right now, a lot needs to be done. It's not going to be easy. I mean, I'm sure the demand might be there, but supply side, there could be issues to give supply in a cost-effective way.
Yeah, that's right. So supply side, there will be issues, but if you look at what if you make say 6 million vehicle, and even if an optimistic number, you make 30% EV, so it's 1.8 million vehicles.
Right.
The IC engine vehicles volumes are still going up.
Correct.
And the truck industry will still remain on IC. Tractor industry is IC. So the best part is the auto component industry who are there in the IC engine business. They are not worried that my business is now stopping and I have to now fund into electric. So if this is going down drastically, where will I get money from?
Yeah, India is going to be one of the last man standing in ICE as well. I mean,
so
that's
if your IC engine volumes are also going up, then your cash flow is coming in. And then if you have technology to get from somewhere or develop, you should be able to find ways and means to invest into it.
So quite clearly what you're saying is, like they've said, it's the ICE portfolio which brings in the profits and funds the future for EVs, and that's going to be there for a while.
Yeah, that's right. Yeah.
Right. And, Mr. Goel, we're running out of time. And I just wanted to ask you one last question is, how do you de-risk or diversify when, EV technology is changing so quickly? We're talking about lithium, but then there's solid state. There could be other chemistries. This also must be something, which is a concern, especially when you have to build capacities and put investments which have to pay off over several years.
Yeah, certainly. I think this is far more important for the people who will make cells. Certainly not that people like us who make Tata AutoComp make battery pack. It also makes a difference there. And some of the equipments are common in the cell manufacturing, but some will be different. So it's a continuous cycle of R&D, in the cell manufacturing industry. So it's a highly R&D intensive organization, but those are say 3 or 4 large groups who would be handling.
Right.
But the auto component industry, like battery pack, we make battery packs out of modules. Modules may go away as far as the cars are concerned, because you will put directly on the new type of chassis like the Tesla does.
Right.
So you'll have to see.
As it is, you've got cell to pack already, which has come with blade cells in a certain way.
But how many of the vehicles will come from cell to pack? How many will remain with the module? And the module machines can be used for solar power. So one has to, very cautiously invest into this. Because whenever you are converting existing vehicle into IC, from IC to EV, you'll always go by module method.
That's right. Correct.
So you make too much investment into it, and then 5 years down the line, everybody is designing grounds up EV.
Yeah, skateboards.
There are no modules required. What do you do with your investments?
Right. It is a bit of a tricky situation.
Yeah.
Right. No, thanks, Mr. Goel. We've run out of time. Thanks for your thoughts. I think, you've raised some very pertinent points. I think clearly what we've heard is that we really need to, it's not going to be an easy ride, especially largely on the supply side. I think the demand is good, but we've got to manage, being cost effective, cost competitive, in producing the components and clearly producing them at scale. But clearly the demand is there. And I think, India is on its EV journey in full swing. And I think, as you said, at the end of the decade, looking at minimum of 1.5 million, that's a big number. And I think that could put us in a very, very, let's say, advantageous position purely by scale. So thanks very much for that, and appreciate you joining us.
Thank you. Thank you very much. Yeah.
Thank you, Mr. Goel. Over to you, Mayank.
Thank you very much, Mr. Goel. Thank you, Hormazd, for that lovely interview session. And, Mr. Goel, how you mentioned about the need for deep localization to drive the cost down further in the EV segment and, increase the affordability of these vehicles. And I would just like to give a summary of the entire day's proceedings. We started off with the keynote address by Mr. Rajeev Chaba, who mentioned about, like how small cars with smaller footprint, which can offer a range of about 120 to 150 kilometers for day-to-day city driving, can be useful for conditions in India where, we have very small distances to cover and we need affordable solutions to make those commutes. And how he's bullish about India's engineering capabilities, to ensure frugal solutions for emerging markets, not just in India, but other emerging markets like Brazil as well. Then we also came to the next panel discussion, wherein we had Mr. Anand Kulkarni from Tata Motors mentioning about the platform commonality that the company is right now using and leveraging volumes to offer its EVs, the Nexon EV and the Tigor EV, at sort of a very affordable prices compared to their ICE counterparts. And in Kia's case, how new technologies like ADAS are adding values to their EV6, which is their sole EV offering in the country right now. And last but not the least, how policy push is, in terms of the lower GST on EVs could be considered as the biggest enabler right now, which is allowing companies, OEMs, to offer these products to consumers at reasonable prices. So we would like to thank you very much for joining for the day one of the Autocar Professional EV Forum, which is powered by Ascent Performance Materials, Covestro, Materials Partners Sabic, and Associate Partners Arkema and ATS. Please join us tomorrow for the second day, wherein we will be talking about developing the EV ecosystem in India. We have a great lineup of panelists tomorrow as well, including Mr. R. Velusamy, the R&D head of Mahindra & Mahindra, Mr. Vivek Vikram Singh, the group CEO of Sona Comstar, as well as representation from Exicom and Sabic USA. So we look forward to seeing you tomorrow. Thank you very much.